All right, let's kick it off. Welcome, everyone. We got a very fun conversation. We got some absolute all stars in this panel. I'll just give a quick intro to everyone. We got Mofi, the deep thinking development machine, who is designed and implemented many of the key components from fault proofs to 4for4 and more at OP Labs. We got Proto, the former pineapple who needs no introduction, who has designed an insane amount of ETH2 and now is applying that same fervor to layer 2 at OP Labs. And Roberto, an absolutely all-star dev at Base, who has been dropping lines of code for 4for4 before it was cool, and a force to be reckoned with for the collective. So this is an exciting stream. It shows the togetherness of Base, and it celebrates the Base and OP Labs and the collective, and it celebrates the coming of 4844. So with that, why don't we kick it off? Proto, could you do us the honor and tell the audience, what's the TLDR on proto dank sharding, and how did we get to this, lovely release?
All right. Yes, let me give you the rundown. So rollups are layer 2. They submit their inputs, their data to reconstruct the chain to layer 1. This process of submitting the inputs and the availability to others for replication is called data availability. And today we kind of use this very inefficient form of this called call data, which is this like resource that really meant for the layer 1 EVM. And so this causes this kind of overhead. And so before we replace this, we replace it with blobs. Blobs provide the data more efficiently and thus reduce the cost of the primary resource that these layer 2s use on layer 1. And this is like a step towards full dank sharding, where we will add more of these blobs.
Exciting. And I know that there's some deep history, and talk about the first hacky 4for4 implementation. What was it, like 2 years ago or something along those lines?
Yeah, so about like 2 years ago at ETH Denver, so not too long ago with the Denver from this year, we're at this hackathon venue, like the old castle, great hackathon vibe. And there was, the merge was on track, like other things were happening in Ethereum also. Now, at the same time, like layer 2 really started to become a thing. We wanted to scale layer 2. And so a group of researchers and developers at the hackathon, we sat down together and we took this original proposal from Dencun and Vitalik to start working towards full dank sharding. And we kind of just, like put this together with people from the Ethereum Foundation, people from Quilt, people from Prism, from Lighthouse, and of course, like the Optimism Collective. And then, like this first draft kind of took shape. We translated into some like early implementation. To call it like a running prototype is maybe a little bit generous, but it gave like this early version of the spec before it was even called EIP 4for4, like like a shape. And then shortly after like that hackathon, we published the EIP and then the consensus specification also.
Oh man, I remember, chatting with you and various other people. Shout out to Onskar back in ETH Denver. It was just a dream then. But Roberto, Mofi, y'all played a huge role in building out the implementation. Share a bit about what your work on the project.
Yeah, I can start. I actually jumped in a little bit later. I was following it closely, but I was tied up with a different project at the time. Luckily, a brilliant engineer at Coinbase, Michael DeHoog, was available, and he started partnering with Proto and Mofi, who laid a lot of the initial groundwork of the initial prototypes. And so I came over. I joined in, I guess, May or something of 2022, not too long after. Michael went on to sort of work on what would eventually become Base. And I took over the 4844 L1 kind of client prototyping effort, working very closely with Mofi and Proto. Yeah, it was kind of like a dream project. I wanted like a meaty L1 Ethereum project. I'd never done that before, and this was just like a perfect opportunity. We wanted to scale Ethereum, so everything just kind of, stars kind of all aligned and jumped right in.
Yeah, and yeah, it was kind of similar to me. Around also like May, right after like Proto worked on the prototype and the hackathon, I was kind of like approached to take on this EIP444 stuff. And at the time, optimism was like going slow on like shipping Bedrock and the next generation, and that's kind of like what Proto was working on. But for me, there was like no one else available, at least internally at OP Labs, to kind of work on this stuff. And at the time, I kind of like just joined, and so like my responsibilities were still kind of like in flux, and so I was kind of like the perfect candidate for that. So I jumped right in, looked at the prototype, iterated on it, looked at the specs, just building like the groundwork so we can have all the tooling and actually have all the necessary code in place so we can start iterating on 444 really quickly. And so we had like all these dev nets, and then Michael DeHoog also joined in, helped write some of that tooling, which was great. And then of course Roberto came in, and we had like a really stellar team, prototype team at the start, but really stellar team. And then we slowly kind of like built up the compadre, as you call it, of people working on the 444. Yeah.
Sick. This, I mean, talk about a meaty L1 project. This is definitely, probably the most exciting L1 project, at least for me, in recent memory. But yeah, so I mean, this is such a cool story because it really, people don't really realize, I think, but also at the time, this is before Base. This is before the, even, this was very early on. I think it started even before, like we talked about the super chain super heavily. And so, this is a real early chapter in the super chain kind of chronicle. Yeah, Roberto, like talk about the, working closely with OP Labs and, what was it like at Coinbase at this time, contributing to L1?
Yeah. So, Base was not really a thing at the time. We just sort of had a mission of driving Coinbase to starting developing on chain. And you remember the early conversations we had with you. We had those same conversations with lots of other teams. We're basically trying to identify a platform on which to build on chain, primarily build on chain, and quickly settle on Ethereum. I mean, it was sort of the obvious choice. Coinbase has its reputation for security and stability and so on. And Ethereum had the developer community. Our only concern was really scalability, right? Transaction throughput was slow. We liked the L2 vision, but we just sort of felt it needed a little bit of acceleration. And yeah, we came across 4844, and this is like the no-brainer thing. Let's go invest in that. And you guys were super eager to, allow us in and participate in that. And yeah, and so that's kind of, I guess, how things took off from there.
Awesome. Yeah, no, this was it was really such an interesting kind of team effort to get this thing over the line. And oh my gosh, looking back, 2 years. So yeah, I mean, when did y'all realize that getting an EIP of this magnitude to mainnet couldn't happen without, full support of the Ethereum community? How did we gather that community consensus, all this stuff?
I think for me, it was pretty early. Just looking at, historically speaking, like previous EIPs and the process of like getting them onto mainnet. Yeah, it's good to have like good implementation, good specifications, and simple enough that it's easy to like for client developers to implement and get it over. But for EIP 444, I think like the complexity of this specification was like on par with the merge, at least compared to everything else that's come since then. This is like EIP 1559, but even just next level than that, right? Because now it like has like a consensus layer component to it, and so it was pretty like clear to me that we not only had to like have like a really good and really simple specification implementation to make client devs really confident of this, but also we had to sell the idea. I don't know if I'm supposed to say this, but like EIP 444 was part a technical challenge, but also mimetic warfare, in the sense that we really had to like sell this idea, get all the client devs onboarded, and this was like built in from the very start. Look into like the EIP 444 website. This is something that Liam, another former OP Labs member, and Vitalik wrote to like have like all the ideas in place, all the memes in place, you know, to like sell the idea. And we just took it on from there really early at the project.
Yeah. Oh, that is such a good point. Like, I remember we had been talking in the Ethereum kind of research community for so long about, you know, moving to a data availability first, moving Ethereum to use data availability and like offer that as a service and optimize around it and do data availability sampling and minimize execution and all this kind of stuff. But I don't know, you would not believe how much of a, you know, hurdle it is to introduce such a new idea. Like, even though it was kind of in the ether, some might say, for quite some time, in the like researcher Vitalik, you know, minds. However, it was a big deal to actually get the community buy-in and the social rough consensus around actually making that first step towards that implementation. And I do think it really helped that that it was you know, made a lot simpler. I think the proto in proto dank sharding definitely helped a bunch with that.
Yeah, I wish I could say we were as well informed on the Coinbase side. We were not. We were incredibly naive, to be honest. We thought maybe this is a 6 to 9 month project, right? We sort of interpreted Vitalik's, you know, roadmap on L2 scaling as meaning to buy-in existed, and it's, you know, just Proto did a brilliant job of simplifying it into sort of a nice bite-sized chunk. We'd get it implemented, and we get prototypes working. Everyone would be excited about it, and we'd get going. Obviously, you know, we had no idea what we were doing at that point. Well, we learned pretty quickly that the complexity of, you know, getting multiple client implementations on board, and furthermore, you know, refining the spec. You know, once you start getting feedback and you start realizing some of the flaws, and there weren't a lot of flaws, but, you know, there were some minor things that required a lot of back and forth. And I think this is, anyone who's been in that EIP process before probably naturally realized that. We hadn't really been deeply involved in that until this. And so, yeah, we learned, I guess, the hard way, but I think it was a great experience. And I'm really, you know, kind of proud of where we landed, even though it took a lot longer than we initially sort of expected.
Yeah, well, you definitely, it's an experience going through the EIP process. That is, you know, those NFTs are well earned, one might say. Anyway, speaking of getting buy-in from core developers, you know, I know DevCon, what was it, 5, 6? Anyway, Bogota was a super important moment for you know, Proto. Tell me about that experience, and like, you know, what was that like? Get, you know, the conference with core devs and all this stuff that went down in Bogota.
Right. So as we were saying, like, it's a long process, and like with Ethereum development, kind of a lot of projects run in parallel, and everybody tries to get rough consensus on like the most important bits that are ready and like, you know, like going into mainnet. but this process is taking more than a single cycle of development for like a hard fork takes in terms of like rollout. Like what it means is that people were still working on the merge while 4.4 was already in full gear, and this meant that not everybody could focus on the one thing for scalability. People had to focus on the merge, and then after withdrawals, like a lot was happening. But I think really after the merge itself, like September 2022, like around that time, people started realizing, hey, like Serenity, like the vision is not complete yet. There's more to build. And it took a while, to like get back into like core development rather than, like trying to polish the merge ever so like to perfection. And I think around DevCon was like the pivotal moment where like people started realizing, hey, this can be done. Like we have a proposal, solid design, there's some momentum. People started agreeing like, okay, we want this data availability solution of dank sharding. And then, okay, like what do we do first to get there? And so the stepping stone, proto dank sharding, got on everybody's radar, got on the radar of implementers, most importantly. And that's how, like at DevCon, we really started to make like a progress towards actual sharding on mainnet Ethereum.
What a journey. What a journey. And I'm sure it was not without challenges. So what were some of the biggest challenges y'all experienced, either implementing it for getting through the EIP process? Anyway, Roberto, kick us off.
Yeah, I mean, there were a lot of challenges. I think one in particular that really stands out for me is lots of data has to be propagated along the network and through the transaction pool. And there was just a lot of ambiguity there. The spec doesn't have to specify lots of those details, right? Transaction pool management in particular is not part of the spec, right? And so what are those rules? Those actually can be quite important to the operation of the protocol. How many blobs to propagate, right? Like we went out initially, I think it was like 8 blobs of 1 megabyte with a target of 16. And then when people started getting a little scared about the amount of data being propagated, it got dropped way back to like 2 and 4. And I think we convinced folks to bump it up to 3 and 6, thanks to a lot of work by folks on the Ethereum Foundation who did some very deep simulations and analysis. But that was the kind of stuff that was really difficult. I wasn't involved in the analysis, but I think that was one of the hardest parts of the overall project, and very thankful to the AEF folks and the Geth team who came up with some really great transaction handling rules, which I think eventually sort of became the standard among most client implementations.
Yeah, the transaction pool was quite a doozy, and glad we hashed that out. I think like personally, big challenge was like figuring out. So like there are some design decisions in the specification that it wasn't quite clear until super late as we got more core developers looking at the EIP to like offer their opinion and provide their expertise and experience to help guide exactly how we should design certain things. And one in particular is like how blobs were kind of like coupled with the beacon block in the consensus layer. The original design was like completely different, and then at DevCon, I kind of like made a proposal to like do the wrong thing. So we ended up coupling blobs and beacon blocks together in consensus, in particular with like peer-to-peer gossip. And then I think later on, some people like thought about it as more core devs looked into the problem. We kind of reversed that decision to like decouple blobs from the beacon block, and just the whole process of like getting through that. It's more than just making like arguments about like what needs to be done, but actually coming up with like doing empirical analysis of like what does it look like if you have blobs and beacon blocks together? What does it look like if they are completely separate? And it was good to have like someone from like the core devs teams that actually did the legwork to prove which proposal was like better. and we were able to make a better informed decision as a result. But it took us a while to get there. But yeah, we got there in the end.
Yeah, I think it was some folks on the Nimbus team that were really pushing for the decoupling, and they did some, again, really good analysis that showed there was like a 30% reduction in latency, if I remember correctly. Don't quote me on those numbers, but it was significant, and I think that sort of sealed the deal. That's the route we were going to go. Even though it introduces a little more complexity, it's going to be more robust, and I think it actually fits in with the longer term game plan towards full dank sharding as well. So that's another really nice aspect of it.
Yeah.
Crazy. Well, we've gone through lots of history, challenges, and all that kind of stuff. But let's talk a little bit about, rubber to the road. What's coming? What's on our horizon right now? So obviously, 4844. Actually, let me give a little context. Layer 2s use there are two resources. There's the L1 data, and then there's the layer 2 computational cost. And we charge for both of these things independently. These are two different fees. So 444 shifts the balance between these fees. Mofi, tell me a little more about this. What's going to happen? What do you expect? How does 444 impact the different components for layer 2 fees?
Yeah, like you mentioned, there's data fees, right? Which 444 aims to directly address. And there's the compute fees for actually, running your code or whatever through the EVM and, doing all the storage and opcodes. Up until like 444, and I guess we'll see in the future, but we've mostly just been focused on like optimizing for data, right? We've like Optimism and most rollups have some way of like reducing the amount of data they have to post back to L1, whether it's via compression or really gnarly algorithms they use to like reduce that data cost, or some might even rely on some like bespoke data availability provider, right? With 444, this would be a much less of an issue. It's always still going to be an issue because, I imagine like there are going to be a lot of applications that will take advantage of this low fee regime, and that might, cause problems again. But this would greatly, like, compared to like what it is today, greatly reduce the cost of like posting data. So I think once you have like this calculus, okay, so now data is almost as expensive as compute, or maybe it's even cheaper as like we scale up 444, then we start thinking about, okay, can we reduce compute? This is like a problem that we've not really invested in because, data is like the biggest component of cost. But I think like in the future, that's where it'll be interesting to see what are the ways we can reduce fees in general across the spectrum.
Yeah, and one thing that I think goes underrated or untalked about with 444 to an extent is that 444 reduces the data costs by, of course, increasing supply of data. But Roberto alluded to the fact that it is still a relatively limited supply of data that we are adding to the system. However, it introduces the cool thing about 444 is not necessarily just the number of blobs or the blob target that we're going for. No, the coolest thing about the system is that the actual foundation for introducing the concept of blobs means that we can now have something that we can just increase the scalability of, increase the number of blobs over time and iteratively improve that and iteratively, benchmark it and test it and improve the gossiping, improve all these things. And that is really the foundation for increasing the speed at which we increase the data. So I would say that really what 4844 marks is it doesn't mark necessarily the kind of infinite data future of, Ethereum or something crazy like that. What it really marks is the kind of new foundation or the kind of paradigm shift of Ethereum becoming a data availability solution, and then turning what was once a research problem from Vitalik and, Dencun into a kind of, prototype with protos, dank sharding. And now that all of this stuff is real, it goes from being more of a research problem to being an implementation engineering problem of scaling things up. So we have the foundation, a lot has been de-risked, and we're gonna hit the gas from here. So anyway, that's my little spiel on why this stuff is very, very sick. I'm not gonna lie. Anyway, now that I'm done talking, Mofi, I got a follow-up question for you though, which is, what does this mean for on-chain users at the app layer? Like, what are we gonna feel? What are we gonna see?
You're gonna feel the burn of low fees. Everything is going to be so much cheaper, which also will unlock applications. I think a lot of app developers have like an idea, and that idea is effectively priced out because fees are not low enough. We will see new types of applications. I can't exactly predict what those are, but I know for sure, like, we'll definitely see new types of applications. It's going to be really swell.
Well, anyway, other people with their speculations on apps. This is. I feel like this is a fun one. I could go, but
I can say a little bit. I mean, I'm really looking forward to smart contract wallets becoming, practical. I think the high fees have been a major burden to this technology. So I think this unlocks a lot of stuff there. Users are not going to have to pay gas very soon. It's going to be the apps that pay the gas to get users to use them. I mean, that is a huge phase shift in the operation of, on-chain activity. And yeah, I think it just unlocks a lot of new possibilities. It incentivizes a lot of new application classes. But yeah, it's anyone's guess exactly how it's going to end up. But that's my stake in the ground. Smart contract wallets are gonna really become interesting.
So sick. Yeah, agreed. And I think we really underestimate the importance and the value to the ecosystem of applications or gasless, the gasless experience and onboarding a lot of users. Because here's the thing that we don't really think about necessarily. It's like, okay, yeah, we can onboard users and we think, and that's already great. And we kind of stop there. But there's another thing that happens when you onboard users, and that is that users generate really cool content and data and interactions and reputations. And these things, because we're in this shared block space, kind of compose and build on each other until you have, really rich user profiles with tons of, cool interactions and games that or ingest data from someone's social feed or like whatever it is, like crazy ideas become possible because of the kind of cross-pollination of these applications. And all of that is enabled because we've pushed down the prices and we've onboarded more users and we've made this a much more vibrant and rich ecosystem. I really don't know if we really are ready for what shared block space can do once it's cheap shared block space. Anyway, I could go on that for a while, but Proto, let's dive back into a little bit of the tech stuff and share a little bit about why is the OP stack so well positioned to, reap these benefits of 4 and lower fees.
All right. So, like as I introduced in the beginning, rollups submit their data to layer 1. And rollups have varying designs, but the OP stack in particular does this very well, where it's just submitting data. It's not doing additional unnecessary layer 1 EVM processing. And so as it's just submitting data, like the primary resource that the rollup really uses from layer 1 is data. And because of this, like as we optimize data, the OP stack really does improve a lot through like this, like more efficient resource.
So sick. Okay, well, keep it on. I'm gonna start peppering in some audience questions because we are actually getting. Well, actually, I do have one more question before I go to the audience questions. Which, by the way, you can ask on Unlonely, please do submit your questions. But yes, Roberto, let's finish it off with anything in particular Base is looking forward to post 4for4 on mainnet.
Yeah, I mentioned smart contract wallet applications exploding. That's definitely my number one. Number two is we're really excited about attestations and applications that take advantage of those. Again, I think the lower costs make that a little more feasible. Attestations allow you to do things like prove that you're human, prove that you're a Coinbase user, prove that you're in a certain jurisdiction, right? So that's going to unlock, I think, some more innovative use cases that didn't exist before. Yeah, and then I'm a big fan of Web3 social. I think, again, the costs there have priced out a lot of users, so that can open up the floodgates for larger uses. Or own your own data, use a client that optimizes your own feed. It's up to you. It's not up to one corporation. I'm very excited about that kind of thing as well. Yeah, I can also go on for a while, but I'll stop there.
Nice. All right, let's dive in. So, okay, first question, is Blob data chain agnostic? So if someone generates data in, say, OP mainnet, it can be leveraged in other L2s.
I think I can answer that. So if we're talking about submitting the data to layer 1, right now, most rollup designs are submitting data individually. I think with the superchain, there's a real potential here to work together as chains. And so every chain, regardless of the size of the chain, can efficiently submit data to the layer 1.
Yeah, it's very cool. Like, the more you submit, the better your compression ratio can probably be. And, we'll get some fun benefits there. All right, another question. This is a quick one, easy one. How long are blobs stored for, and where are blobs stored?
This feels like a proto question given he wrote the spec. It's basically 18 to 21 days, roughly speaking. They're stored in the consensus layer. That is the mandated retention period, by the way. Some clients will be configured to hold on to them longer. One thing we've done with OP Stack is we've released something called a Blob Archiver, which is a really lightweight tool where you can store blobs that you're interested in, all blobs or blobs that you're interested in, either to a file or to S3, and then be able to point an OP Stack client at that archiver if you want to do like, sync an archive node from the beginning in a very straightforward way, for example. So yeah, there'll be numerous ways to get at blobs, but in the strict protocol, yeah, it's about 18 to 21 days.
Nice. And I do have a follow-up question here. So one question that I get a lot with 4for4 is like, are we making trade-offs? Like, are there things that we're, losing out on with this upgrade, or is it just pure upside? And one of the things that I often have to say is like, hey, Ethereum goes from being, storing the call data, which is where we post the rollup data previously, kind of forever, at least that's kind of the tacit social contract, even though it's not technically necessary, to this 18-day, period. And I try to articulate, why is this actually not really a negative trade-off? So I don't know, describe like, why is it okay that Ethereum is like, it seems on the surface like, oh my gosh, Ethereum's only going to store the data for 18 days. Why is that fine? Why is that actually good, arguably?
I can make an argument for this there are two arguments. I think the primary argument is how Ethereum prioritizes its security model. That security model, right now, it's spread very thin across all this history, whereas it could be, put its weight on the latest data, the data that's contested. Like there's contention about every input to a rollup. This is what users rely on when proving the outputs of these rollups. Like this is where most of the value is, being able to agree with the whole world on like the latest change to the layer 1 system. This is very valuable. Whereas data that's widely agreed upon like that's the older data, and this is data that doesn't need as much of this attention, whereas layer 2s have a lot of incentive to host this data and to also optimize it to allow you to sync it in better ways than reprocessing all these raw inputs. So overall, it's like why I'm happy with this momentum towards more focused resource, really.
Nice. Yes. Oh, yeah. Agreed. That's very well put. Like, something that we don't really recognize is that the thing that Ethereum is doing is it's creating a record of all of the transactions and what order they come in. And there's lots of contention. I want to be first. I want to trade before that person. I want to deploy this smart contract. That needs to be created. But once that record is created, you can always verify the data against the record if you keep it yourself. And so it should not be Ethereum's job, or at least it must be a different person's job to keep that data around versus coming up with that ordering itself. And so actually, a lot of the times, scalability unlocks come from modularity and creating more special purposed systems to solve special problems so that we don't kind of bundle everything together and get the worst of all of the different security properties. And so this is actually a move towards, honestly, modularizing Ethereum, which is very exciting. Anyway, enough buzzwords. Let's go on to another question. Okay. Let me see. Will blob hashes be accessible in the EVM to verify the data blobbed? If data was blobbed.
Yes, they will. So the EVM still has a job of, like doing settlement, putting data out of these layer 1s or out of the layer 2s into the layer 1. And being able to interface with the data this way, being able to authenticate it, most importantly, yes, this is very much a feature of the EVM. So blob hashes will be part of the upgrade too, but not the full data.
You gotta know your blobs. Okay, so how many OP stack execution / consensus clients support the upgrade currently? It's usually a good question. I don't have it off the top of my head.
I don't
All
know
of them.
off the top of my head either, but yeah, I think all the major ones. I think OP Reth now supports it. Certainly, OP Geth obviously supports it. I would assume Nethermind as well. I don't know for sure, but I know Nethermind had a Reth compatible client. I don't know if anyone else in the room here knows.
So specifically, are we talking about the layer 1 clients or the layer 2 clients?
OP stack. OP stack.
OP stack. So with OP stack, we have a similar separation of concerns as in layer 1. We have execution and consensus. And the execution clients will all just work out of the box, given that they're, they don't have major changes that you required for FART. The consensus layer in OP stack does have some more changes. That's, converts the layer 1 data, the blob data, into these layer 2 inputs. So I think you will need the OP node there to start, but I hope to see more consensus layer clients of the OP stack, like the Rust client, Maggie, to also support blob data.
Nice. Well, this is the beauty of multiple clients and a large contributor ecosystem to the collective. Okay, another little fun one. Actually, maybe we only have one, kind of almost time for one more question, but we'll end it on the most crazy and speculative question, which is, tell me exactly how much the fees will be post 4 and if you are wrong, I will hold it against you.
We should have this is a betting pool question, right? In fact, a betting pool exists and some prediction market exists. I'm blocked from it naturally, but yeah, I think there's a lot of guesses. The quote I've been providing to media is, 10x to 100x. Or 90 to 99% or whatever, right? It'll be more to the 100x initially. I think Proto has done some great analysis that shows if you look at all the L2 data that's being written as call data right now, there's more than enough blob space to hold all of it, which means the blob fee market will be at the minimum. So yeah, that if that's the case, it's going to be huge. We don't expect it to stay that way for long, right? When there's induced demand, there'll be more transactions. There'll be clever uses of blob space that pop up. Who knows what, right? So that market will achieve a little more equilibrium over time. Anyone's guess exactly where that ends. If you think you know the answer, go to that prediction market and make a lot of money, I guess.
All right. And with that, make sure to go to welovetheblobs.xyz to, take a look at some various estimates, or just transact on any of your favorite OP chains, any of your favorite chains within the super chain in just a couple days. We've got an absolutely action-packed week ahead of us. And, thank you so much to all of the incredible panelists. And not only for the panel, but also for shipping 4 for 4 and all this kind of stuff. It's been incredible.
Cool. Thanks for having us.
Yeah, this is great. Thanks.
Shout out to all the layer 1 developers.
Yes.